Hey guys, this is Taylor here, and today we are solving the problem number 3635, which is earliest finish time for land and water rides too. So you are given two categories of theme park attractions, land rides and water rides. Land rides, land start time, the earliest time the ith land ride can be boarded, land duration, how long the ith ride lasts, okay, and water ride is same thing. So a tourist must experience exactly one ride from each category. So he need to take exactly one ride from this, exactly one ride from this. A ride may be started at its opening time or any later moment. If a ride is started at time t, it finishes at t plus duration time. Okay. Immediately after finishing one ride, tourists may board other ride. It is if it is other already open or wait until it's open. Okay. Return the earliest possible time at which the tourist can finish both rides. So let's understand what is given to us. By the way, this question is the extension of the first question of the Biweekly Contest 162. So if you haven't watched that video, I will put that in description. You can watch that. So in that video, we had discussed the brute force approach, and in this approach, in this question, we will be solving it little optimally in order of n time because the constraints are here. It's n, I think 10 to power 4. So let's try to solve that. So we let's understand what is given to us. So we have given this land rights. So we have one and two land rights and one water right. This is the start time of land right, start time. This is start time of water, and this is the respective duration of this. Okay. So if it starts at 2, okay. So I need to wait for 0, 1, and 2 seconds. Then it takes 4 seconds, so I will add 4. So at 6 my first ride can be completed. And if I go here, so do I need to wait? I don't need to wait. It starts at 6 and current seconds are also 6, so I can immediately start this, right? And I will take 3 seconds of duration, and my resulting will be 9. Okay. Or either we can do other way. We can select this one first, wait for 3 seconds. I mean, say wait for 6 seconds. Start this right. Duration is 3, so 6 plus 3 is 9. Plus, this ride is already started in this 9, so I don't need to wait. Now I will be adding just the duration. So 9, 4, it's 13. So this is the duration if I take this ride first, then this ride. So in this way, there are a couple of ways. There are actually n into m ways. So I can take this one, then this is way one. Then I can select either this first, like this first, this second, or this first, this second, or this first, this second, or this first, this second. That way. So n cross m into 2. That will be the total combinations in this. So I would not be doing a brute force that we already did in the first question of the contest, and it was able to submit because constraints were just 100. But in this case, constraints are something like this. So we need to think something optimally in either order of n or either of log of n. So n log n, I mean. So the idea behind solving this problem is very simple. You just need to think in terms of possibilities. Okay. So the very first thing that should be noted, that should be observed is I need to select one right from here and one right from here. Okay. This is the first thing. What is the second thing? Second thing is ideally, I would think of selecting the minimal, the right which is giving me the minimal. So if I sum this up, let me sum this up. So maybe we get the better idea. So this is 6, this is 9, this is 9. Okay. Now, this is taking 6 cost and this is taking 9 cost. Okay. Uh, Fine. So what I can do here in this situation, I think if I ask you to select one right from this and this, which one you will select if you have to complete it earliest? I think you will select this one, right? And there is only one option, so you have to select this one. So that's the idea behind this problem. So what is the possibility? What we'll be doing is, first thing, we will select the minimum right. Okay, all we will sum up all rights like this and we'll select the minimum. Minimum of length. Okay, we selected minimum of length. Now we will try to combine this ride with every ride of water. Okay, and we'll check key whether which one is giving us very small answer, the earliest possible answer, minimal answer. And we will do same thing for this. So we will, let's say, let me bring one example. After this, then you will understand properly. So I will select the minimum of all this. Let's say here 10, 12, and 8 is present. So I will pick this 8. Okay, and I will select from this. I have selected it. Now which one is suitable, most suitable? So it's giving me start time, this duration, this is start time, this duration, this. So I will compare this 8 with these things, and I will try to find out the optimal answer accordingly. Okay, so these are just two simple steps, and then we will be definitely done with this question. Let me bring one test case, then we'll definitely able to understand easily. Okay, so here is my test case. In this test case, I am having 3 land rides and 3 water rides. Okay, so what I told, I will do one thing. So what will be my case one? Case one will be, let me write with yellow. So what is my case one? Case one is select land ride then water ride. Okay, and what is my case 2? Case 2 will be select water ride then land ride. So this is the two simple things. And how I will be select, so I asked you, right, if you have to just select land ride and you want earliest finish time, what you will select? You, this one or this one? I think you will select this one, right? You will select this one, definitely, yes. So I will select this one. Okay, now what I will do, I will try to pair this with this and this, all this thing. Okay, so I will try to do this thing, and I will check okay, what is my basically answer. So this is case one I'm exploring. Now here I am completing in 8 seconds. Okay, 8 seconds. Now I'll see. Do I need to, if I tried this right, do I need to wait? No, I don't need to wait because it's already started. So what is the duration of it? I think 8 plus 5, it's 13. So okay, fine. This, if I select this right and this right, it's costing me 13 seconds. So okay, next thing. So I will pair this with this, I think. Okay, so it completes it in 8 seconds. It starts in 9 seconds. Do I have any waiting time? Yes, I am having a waiting time of 1. Then what is the duration of this? I think 2 is the duration. What is the total cost? 8, 9, 10, 11. 11 seconds. Superb. Now this one. So 8 seconds and 11 seconds. Do I need to wait? Yes, I need to wait. How much? 3 seconds. 8 plus 3. What is the duration of this? I think 1. So 8, 9, 10, 11, and 12. So here we got a 12 second, 11 second, 13 second. I will keep tracking of this minimum. So 13, 11, and 12. I think my mini so far is 11. Okay. Now let me bring down case 2. And in case 2, what we'll be doing? We'll be taking minimum of this and we'll try to pair up with all these 3. I think this is my minimum. Let me color change. This is my minimum, right? So I will try to pair this up with this and this, all 3. Okay, super. So let me do that. So 11 plus this ride ends at 11, at 11 seconds. It starts at 9, it completes in 2 seconds. So it total, or total cost is 11 seconds. So this ride is already started. Do I need to wait? No, I don't need to. So this ride is taking a duration of 10. So my overall cost is 21. Super. Now this completes it in 11. It starts at 3. Do I need to wait? Do we have any waiting time? No. I just have to add this duration. So 11 plus 5, it's 16. Okay. Now this, okay, 11 and then 9. Do I need to wait? No, I don't need to wait. So 11 and 9. Uh, Do I need to wait? I don't need to wait. So what is the duration of this? I think 11 plus 1, it's 12. It's giving me 12, 16, and 21. Can I compare with this? I think 11 is the minimum. So this will be my ideal answer. So this way we can definitely write some code and get my answer easily. Let me quickly write pseudocode for this and then we will be coding this. I hope the approach and intuition is clear. So the intuition behind this is only thing, if you have to select this right, so which one you will select? I think this one, because this is giving you minimum. So I will select this one and I will compare this with all these three. Okay, that's the only thing. So if I select water right first, and which one you will select? I think 11, because this is 12, this is 12, this is ideally small. So you will pair up this thing with all these three and see whether which one is giving you most minimal answer. Okay, so let me write down these things quickly. So uh, land minimal equal to 0, and I will be treating over I equal to 0 to n minus 1, where n is length of land and m is length of water rides. Okay, how many water rides and land rides are having. Now, what is the next thing that I need to do? So I will just I think I need to start it with infinity. Then what I need to do? I need to compare land minimal, land mini I can write here is minimum of land mini, comma, should be underscore, comma, land start time of I plus land duration of I. Okay, and similarly I can calculate my water mini infinite. I will start for I equal to 0 to m minus 1, where m is length of water. What I am to do, water mini equal to minimum of water mini, comma, water start time of I plus water duration of I. So this loop is doing what? This loop is basically calculating. This loop is basically calculating what is a minimum of this. So land mini will be having this. Water mini will be containing this. Now I need to first pick this and compare with all these three, and then second thing I pick this and compare with all these three. Okay. So that's the only thing which is remaining. And let's quickly write this. So case one, where land then water. So I know my land right is this, so I will be treating from I equal to 0 to m minus 1. I have to compare with every water right. What I will be doing, I will first calculating the wait time. What is the wait time if there is any? I will be checking wait time maximum can be 0, just to avoid negative numbers. And what is how I can calculate? I think the water start time of I minus land duration, land mini I think. Okay, land mini we have named it here. So what we are doing here, basically we are checking. So if I pick this 8, okay, and I'm checking, so here I got a 9. So to calculate the wait time, I need to subtract 9 minus 8 equal to 1 second. So this is the thing that we are doing here. So that way I will be able to calculate the wait time. Now what is the next thing that I need to do? I think I need to track the mini. So mini I will be starting from infinite, and mini equal to min of mini, comma, how I will be calculating the answer? I think the wait time plus what is the duration in water? Okay, water duration of I plus this land cost, land mini. So let me explain what we did here. So what we did? We need to calculate. So I picked this 8 plus my waiting time, 9 minus 8 waiting time is 1, plus duration of this 2. Simple. So I got 11 here. So that's the only thing. The same thing that I will be doing for I think this also, uh, case 2 also. Case 2 will be water, then land. Okay, so I will start from 0 to n minus 1 this time, and wait time I will calculate is max of 0, comma, land start time of I minus water mini, and mini will be minimum of mini. I hope you got it right. Wait time plus land distance. I'm writing in a little bit bad handwriting, sorry for that. Water mini. So I hope you got it, and in the last we can return mini. So let's quickly write down code for this. I think this was not a very difficult problem. So length mini equal to water mini equal to float infinite. Okay. What is the next thing I need to do? I need to calculate the land mini and water mini. Length of land start time, length of water start time, superb. And it will go till end. Land mini equal to minimum of land mini, comma, land start time of I plus what land duration of I. Superb. Now I need to calculate water mini also. For I in range M, water mini will be minimum of water mini, comma, water start time of I plus water duration of I. This way I will be having my two things. Now case one is land, then water. Okay, so for I in range, and why I'm writing M, because I will be comparing for every water. Okay, so wait time I will be calculating first of all max of 0 comma I think land water start time of I minus land mini. This way I will calculating the wait time. I think mini I can initialize with infinite, and I can keep computing my mini as minimum of mini, comma, wait time plus land mini plus whatever the duration of water of I. Okay, and similarly case 2 will be water then land, and for I in range and wait time will be max of 0 comma land start time of I minus water mini, and the mini would be minimum of mini, comma, wait time plus water mini plus whatever the duration of water land duration. Okay, and the last I can simply return a mini. I hope you got it what we are doing here and how we are doing. Let's quickly run this. Okay, it is working fine. Let me submit this and see. Yes, it is submitted. So I hope I am able to explain you this problem, and if you see the hints and all, na, it's telling you to build a prefix sum array and do binary search, do lot of things. But I would not suggest doing these things because this problem is simple to understand and we don't want it to make complex unnecessary. So I hope I am able to explain you this tough problem easily in easy manner. So in case I did, please make sure you subscribe to the channel. That will definitely motivate me in creating more such insightful and easy solutions. And thank you very much guys for watching this video. Thank you.